Hi Dhanushri. So we have pretty much everybody. Hope I'm not missing anybody. So let's look at what are the things that we're going to cover today. So till the last class we learned about ellipse. We learned about we did not cover parabola, but we compared ellipse formulas with circle formulas, and then we learned about foci. Then we learned about the focal length of ellipse and how do you relate things. What I got you guys confused about was more around hyperbola, right? So that's where we started talking about it, but then I was myself not convinced, right? Because I keep on assessing how I'm teaching you guys, okay? So I did not feel very confident about what I covered in the previous class about hyperbola. So that's what we'll try focusing on, and hopefully we should be able to learn all the related concepts about hyperbola in the class today. So just to summarize, the things that we're going to talk about are going to be primarily around what is hyperbola, understanding of the properties of hyperbola, and then analyzing or comparing the formula. And then we will talk about how do you graph it, how do you find the vertices and the direction of hyperbola. And then we'll talk about how do you find out the foci, what is foci of a parabola, and then we'll talk about how do you move a parabola just by looking at the equation. How do you visualize or create a picture of how parabola is moving, how the asymptotes of the parabola is moving, and then how do you create a picture of that when you have to kind of visualize that. Okay, so is that lay of the land okay for you all, or you have something else about hyperbola that you would want to talk about? No? Okay. All right. So as we briefly touched upon, hyperbola is another part of a conic section when you have two cones sitting on the top of each other, and then you take a plane for dissecting or cutting it using a plane. And when you do so, you can look at this like a saw, which is kind of cutting this. And then when you picturize, when you cut this out, and then you look at what shape you are getting as part of this plane that is cutting it, you will see that this is the kind of a shape that you come across, which is called hyperbola. So we know if you are only looking at this, you are looking at a parabola. When you have two parabolas together with some kind of symmetry around it, that's what is called hyperbola, right? I mean, we know a mall and a hypermall, right? When you have something more than a mall, market and a hypermarket. Similarly, parabola and a hyperbola. There are two parabolas relating to each other in a common place, and then when you look at them together, that's what is called hyperbola. Very, very simplified definition of how do you visualize a hyperbola, right? Now, let's look at how do you mathematically go about a hyperbola. So this picture will not use anymore, and whenever we talk about a hyperbola, we are talking about a hyperbola like this, a pair of parabolas one facing upward, one facing downward, or you can also come across a situation like this where you have hyperbolas horizontally aligned. Yeah. Now, when is this facing upward, downward, when it is facing sideways, those are some of the internal interesting details about hyperbola that we want to cover. So let's talk about it. So you all have seen circle equation enough. X squared by r squared plus y squared by r squared equal to 1, or you can say x squared plus y squared equal to r squared. This is a form of a circle equation where just by looking at this, you know that the origin of this is at 0, 0, meaning on the center of the circle is at origin. This is 0, 0. If the center of the circle is not at the origin, you know that the circle equation changes to x minus h squared plus y minus k square equal to r square, where h and k are the x and y coordinates of the center. This one is okay, right, so far? Now, this becomes the parent of all the equations that we'll deal with in the entire conic section. So that's what we touched upon when we said, okay, fine, if you squeeze this circle and make this an ellipse, this is what you're talking about. You have a major radius, minor radius. Or this is a major axis, minor axis. And here to here, this is called your minor radius. Here to here, it's called major radius or semi-major radius, any which way you want to talk about. And then your equation changed from this circle equation, the equivalent of this in the ellipse was x squared by a squared plus y squared by b squared equal to 1. Here, instead of r, since you don't have one common radius, you have two variants of the radius. That's how the major radius becomes a denominator for x squared, and the minor radius becomes your denominator for the y squared. And this is a situation when your ellipse, center of the ellipse is at 0, 0. If the same ellipse's center is not at the origin, then this equation gets an equivalent of this circle equation, and that is x minus h squared by a squared plus y minus b squared y minus k squared by b squared equal to 1. And you guys will think that why this old man is going through the same thing that he has taught us before, right? Because I'm trying to draw a parallel to this and use this understanding to look at the equation of hyperbola. So these things, as long as you guys recall, it will help us go to the next level of discussion, which is hyperbola. And I believe everybody is with me so far, right? Yeah. Now, what hyperbola says is, there is a very close similarity between anything and everything that you have learned with ellipse. I mean, if I look at it in layman's term, right? If I look at this hyperbola and this ellipse, what is happening is, if I look at cutting this into two pieces and flipping this sideways, this is what I'm getting. I mean, it's not a perfect mathematical analogy, but more from a usage point of view, if you want to visualize this, you can say that, okay, if I have the ellipse, if I cut it into two equal pieces and then I flip both the pieces, this is what I'm going to get. So that is why there's a relationship. Now, why I was trying to cut this open into two pieces and flip it, right? Because I was trying to show you guys that, okay, now when I have this thing here, when I'm cutting it open and creating a mirror image, the center that was here, my center remains here. Okay? Just the two pieces got flipped. So there will be a lot of things common here. Okay? Now, when I flip this, now look at this. One of it will become a mirror image of the other piece. And hence, if I just add a flavor like this, this becomes my equation for the hyperbola. So if you relate in the simplest form, what you're saying is, one of my thing is going around the positive side of x-axis, and other thing is going the negative side of x-axis. That is how I have to have a flavor which is taking care of that flip, that switch that is happening. And again, this is not a legitimate definition. I'm just helping you guys relate. So I have the equation for ellipse. If I introduce a minus, earlier in my equation of ellipse, it was x squared by a squared plus y squared by b squared equal to 1. If I introduce a minus, meaning I'm cutting it open and I'm bringing a negative flavor of it, that becomes my equation for the hyperbola. Same thing here, it was plus before with the ellipse. I said, okay, now this. So I have a negative flavor of this also. And this becomes my equation for the hyperbola. Any questions here? Or any confusion here so far? No confusion? Okay. So this becomes our equation for the hyperbola. So hereafter, whenever we talk about hyperbola, we will say that the equation that I had for ellipse, I'm going to reuse the same equation, and that will be my equation for the hyperbola. So basically, x squared by a squared minus y squared by b squared equal to 1. My ellipse had a plus. I replace that plus with a minus because I am flipping it on the negative side of the coordinate plane. So I have a negative and a positive, that's why I am putting a negative here. Now, this something very unique that you would want to talk about. If you visualize a hyperbola, you will see that it's flipping along or flipping across or creating a mirror image across the y-axis, or if it is facing upside down, it is creating a mirror image along the x-axis. And we'll come to that. So here, if you look at the first scenario, any point and every point on the hyperbola, if I draw a tangent, that gives me the slope. Here in this case, we talk about something called asymptote, meaning the line or the maximum points which defines the boundary of this, where for the value of certain value of x, y starts tending towards infinity, or that will be my vertical asymptote, and value of y for which x starts moving towards infinity, that will be my horizontal asymptote, as we have learned before. But we are just trying to relate it here. In simplest form, if you talk about any asymptote, we are essentially talking about if I am looking at it with respect to a hyperbola, we are essentially trying to find out the boundary, or these two perpendicular lines which is defining defined in such a way that this hyperbola is lying inside this one. And so just to relate, now let's look at this equation real quick. If I had this equation as my equation for the hyperbola, so that let's not go to asymptote, okay? Let's quickly look at this equation in simplest form. So if I look at this and try finding out the value of y squared by b squared will be equal to minus, this will be 1 minus x squared by a squared, or y squared by b squared will be equal to x squared by a squared minus 1, or y squared will be equal to b squared multiplied by x squared by a squared minus 1. So what is exactly that I am trying to do here is just trying to build an understanding about what this equation for hyperbola gives us, and how do we define the boundaries, how do we identify the asymptote within which my hyperbola is existing. So if you look at this equation, this was my equation. What I am trying to do is I am trying to find out the value of y. So y square equals to, just by simplifying this one, I am getting to a point where y square is equal to b squared by a squared times x squared minus b squared. So I am just breaking open this bracket, and this is what I got. So y equals square root of b squared by a squared into x squared minus b squared. So whatever I did, okay, even if it looks confusing, don't worry about it. I'm just, from this equation, I am to find out the value of y. Now, what is the main purpose here? We are trying to find out, because we know that hyperbola is, see, when I extend it further, it will probably tend towards infinity. Here also, when I assume that this is going further, if the value of x keeps on increasing, it will at some point in time it will reach towards infinity. Where exactly it will reach, let's not worry about it for now. But just by looking at this equation, let's try to figure out what happens when my value of x reaches towards infinity or gets very, very close to infinity. We are trying to find out, see, if I look at this one, this hyperbola, right? So let's say this is tending towards infinity. So, but the good thing is, I mean, let me rephrase it. So let's not look at two things together. So let's look at it mathematically only. Let's not look at the visual part. This is my equation. Now, what happens when x becomes too big a number? As good as infinity, maybe a trillion, maybe hundreds of trillions, gazillions, Google, whatever number you can think of. If x becomes so very big, what will be the impact on this whole thing? This will become negligible compared to this, right? If you have this as infinity, whether you are multiplying infinity with 5 or 205 or 1 million, doesn't make a difference. It is still infinity, right? Then you will tend to ignore this number. Am I making sense so far? So one more time. So this is my equation. From this hyperbola equation, I came to this point where y equals to plus minus this value. And I'm just saying, what will be my value of y when x tends to infinity? I can safely ignore this one because infinity minus 5, no relevance. I will not even talk about it. So in that case, similarly, this whole thing also doesn't have much impact on this one. As long as this is not 0, we are fine. Infinity times 0.1 is also infinity only. So we don't have to worry about it. So what we are trying to derive here is, this is a relationship between y and x, where we are saying, okay fine, if I have x tending towards infinity, I can simply ignore this part and this becomes b square by a square times x square, or y equals plus minus b by ax. So here, this is what is called the slope or the asymptote of this hyperbola. Now you will say, why we are saying this asymptote? Because this says that what is the value of y when x is tending towards infinity, and what will be the slope of this hyperbola when we look at the situation when it is tending towards infinity. Okay, so the practical relevance of this y equals to plus minus b by a times x, the asymptote or the slope of this hyperbola is as simple as saying that, let me write it one more time for you guys. This says that if I have a hyperbola and if it's reaching towards infinity and this converted to plus minus b by a times x when it's reaching towards infinity, so this is essentially a slope or the rate at which y is changing for every change in x, meaning essentially this is my slope. These are called your asymptote for this hyperbola, which defines the boundary that okay, even for the highest possible value of x, my slope or the rate of change of y against x is going to be defined within this boundary. Is it making sense so far? Yeah. And trust me guys, I mean, you don't have to say yes if I'm confusing you guys. I mean, I'm okay saying the same thing 5 times also. Dhanusri, Chris, Dave, are you guys clear?
Yes, sir.
Okay. So basically, the summary here is, If I have an equation for the hyperbola and I visualize this, what will happen when my value of x changes to infinity, and what is the relationship between x and y, or the slope which is defining the boundary of this hyperbola. This is called my asymptote. So whenever you have to visualize a hyperbola, you have to say, okay, fine, this first you have to find out the asymptote, meaning the defining boundary, and then you will say, okay, fine. Now if you look at this equation, here there's a value that is getting deducted from this one. So y value will be always not touch this asymptote, but it will be slightly below this, Okay, so your hyperbola will be plotted in a way that it is very close to the asymptote, but little bit under it. Okay, you will never have this asymptote like this and then your hyperbola goes like this. It has to be inside this, because that is defining your outer boundary or the slope of the parabola, which has to be higher than the maximum slope of this hyperbola. Yeah. Okay. So sometimes when I myself not sure that if I'm able to explain this to you guys clearly, I will take a pause just to make sure that I get a concurrence from you guys. Now I have just talked about one situation when my hyperbola is facing sideways, meaning along the creating a mirror image along the y-axis. So this is facing sideways. So one is facing right, one is facing left. Yeah. So here there is another situation when a hyperbola could be facing upward or downward. Now you will tell me, how do we get that? The second situation is when my hyperbola is facing sideways, my x term is positive, and you will tell me why so. We will come to that also. So there are two variants of a hyperbola that we are talking about. One variant is when, in case of ellipse, we saw that x squared by a squared plus y squared by b squared equal to 1. This is one common equation that is used, and there is no variant to that. There is no change to that. But in case of hyperbola, we said that one of the term will be negative. So this time we picked up this term as negative, meaning the term which is mapping to y as negative. And if we pick another situation where y squared by b squared minus x squared by a squared equal to 1, that is the second situation of a hyperbola where it will face it upward. Now you will say, why do we believe you? So let's look at it. Does anybody in the class have any thoughts around why this changes this from sideways to upward or downward? And any random thoughts? Okay, so that's fine. I mean, I'm not trying to put you guys on the spot. Let's look at it. So first look at this. In the first situation, what we saw was, now this is my, so if I look at this situation where we found that y equal to plus minus b by ax when I'm reaching towards infinity, okay? We found in this case. So from this one, this equation also tells us my value of y depends on b squared by a squared minus into x squared minus b squared. This was the initial equation we found from this one. So what we saw was this, the value of y is always lesser than the asymptote. So if this is my asymptote, let's say this parabola doesn't exist. If I say that this is my This is my parabola equation from which I get the value of y. So I'm saying y is, this is my asymptote, this is the slope, this which defines the maximum boundary. But a hyperbola could be this way, upside or upward or downward facing or side facing. Now here we saw that this value of y is slope times x minus some value, okay? Meaning y has to be less than this value. If it is here, let's say if you pick up a point here, okay? Let's say my hyperbola is in this place. That cannot be possible because your y value has to be slope multiplied by x. See, if you look at this, if you remember the y-intercept form of the equation, right? This is a slope. Look at this as a slope. And you have a minus. So, at any point, this has to be below this asymptote. This is my positive asymptote because the slope is positive here, and this is my negative asymptote. So, okay, now let's look at this. So here when we are looking at this the first equation alone, okay, I know it might need a double click just to be doubly sure. We got this is my slope for the limiting situation when I'm hitting the asymptote, or this defines my maximum slope, right? So my hyperbola has to be within this one. Now when I'm looking at any point on the hyperbola, it has to follow this contract. Right? This is my contract for the hyperbola, and it has to be, the y value has to be less than the slope times x minus some value, right? Are you with me? There's a minus that you see here, right? That's why it says this value of y has, if this is my positive asymptote, this is my negative asymptote, right? Because here, when the value of x is changing, increasing, value of y is decreasing. So we are not, this one anyways is a decreasing one. When you look at the increasing asymptote and then you are trying to figure out where exactly this y will lie, when you see a minus, that means it has to be below this. Because unfortunately, this guy has not even gone or touched the asymptote anywhere. It is slightly below this because there is a minus here. Similarly, so from that one, if you look at this equation, you see that this equation tells you that my y value has to be little less than the slope. Meaning at any point in time, the slope of this asymptote will be more than the value of my y. Meaning y has to be less than that, then only it will be qualifying this criteria. Am I making sense, Chris, Dave, Tanushri, Pisha, everybody? Now, so this minus is a symptom which tells you that okay, my y value is less than the slope. So it would be somewhere here. If it is anywhere here, that means it has gone above the slope. So this is not a possibility. Now we look at the second equation. That might give us another clue. So now let's look at the second equation. This equation we saw that here when my x is positive, my y value is in the slope times x squared minus this, and that's why we are coming to a point that we are thinking that this is falling here, and the other one has to be a replica of this. Now let's look at this equation and what happens in this case. So it becomes y squared by b squared equal to 1 plus x squared by a squared. That is one difference that you can see here. Now when y squared, you are trying to find out y squared, it becomes x squared by a squared times b squared. It goes that side and gets multiplied with everything, so it becomes this. Or y will be equal to plus minus square root of b squared by a squared x squared plus b squared. So if you look at this equation and this equation, both are exactly the same. Only difference being this has a minus sign, this has a plus sign. So here also, if you imagine the same situation, when x tends to infinity, you will ignore this. This becomes your slope for the asymptote. So essentially, equation with y term being negative or x term being negative, your slope for the asymptote is the same. Meaning, you get the equation, find out b by a times x, or d by a gives you the slope, and you can just draw the asymptote. Now whether your hyperbola will be lying here and here or here or here, that you will be determining by looking at this equation or by looking at this one. Now you look at this one. If you look at comparing this part versus this part, where here you have minus b square, here you have plus b square. So this one tells us that okay, my y value has to be somewhere above the slope. So if this is my positive slope, my y value of the the hyperbola has to be above this one. And if I am looking at it from negative side, it has to be below this one. So basically, if this is, let's say here y is minus 6 here, and here it is minus 7, let's say. So this one is greater than this one, right? So here we are saying whether you are looking at it from the top, meaning the first, second quadrant versus third, fourth quadrant. If it is plus, it is above the asymptote, or that means your hyperbola is getting very close to it, but not exactly aligning with the asymptote. It has to be a little above that because you have a plus. So in absolute terms, any point on the hyperbola will be aligning with this form, and then the value of y will be little more than slope times x plus a marginal difference. Okay, it could be as small as you can think of, but it will be above this. So what is the conclusion from this? What did we see? When I had my x term positive and y term negative, this tells me that my hyperbola is facing sideways. When my y term was positive, x term was negative, my equation was having a plus here apart from the slope. That means it will be above this one, so it will be facing upward and downward. Is this part relatable? Yeah. So now a very simple situation that you guys will deal with. Okay, you will be given a question, let's say something like this. Okay, that you have a hyperbola with the equation x squared by 9 minus y squared by 16 equal to 1, and you'll be given 4 pictures. Okay, and then another one. Okay, so just by looking at this equation, you have to find out which diagram is representing the hyperbola that will be derived, or graph that will be graphed using this equation. So here you have to use elimination technique. Now what we have seen, if you look at the summary of what we have discussed so far, is you have your x term positive and y term negative. So if x term is positive, meaning x positive, it's all about x along the x-axis. It doesn't have any y intercept. Okay, so or it is facing along the x-axis. When x is positive, it's facing along the x-axis. So from these 4 options that you have, as soon as you saw x term is positive, you will discount this one and this one. Now you are left with 2 options, this guy and this guy, and you have to choose which one is the right one. Now the next thing that you have to look at, that is called vertices of a hyperbola, or the center of the hyperbola. So by looking at this one, so as I said, if it is x minus h squared by a squared minus y minus k squared by b squared equal to 1, then my center is here, h and k. But since I'm talking about h, there is no h and k, meaning h and k values are 0, meaning this is at the origin of the, my center is here. And interestingly, in case of hyperbola, your center is always outside the graph that you see, because you have cut it open, right? So it is always lying here, outside both the hyperbolas. Okay. So by looking at this equation, you know that okay, fine. So my center is 0, 0. Now, since this is facing in the along the x-axis, this is, what is this one? X squared by a squared. A is nothing but the, if you relate that with the equation of the ellipse, right? What is the a? A is your length, minor radius along the x-axis. So is the case here. So this is your distance of the center from this vertex. So here, if it's 0, 0 in case of ellipse, right? This becomes a, 0, correct? This becomes minus a, 0, right? If a is your major radius, and similarly this becomes 0, b, and this becomes 0, minus b, right? So same way you can relate. So the edges, these are called vertices or the vertex, whatever you call it, of the hyperbola. So here in this case, what is your length along the x-axis? That is, this is 3 square. So this is a, and this is 4 square. This is b. So here you are talking about this point as center is at 0, and along the x-axis, this is the edge, which is the vertex. This will be 0 plus 3. So 3, 0. This will be your one vertex, and the second one will be obviously minus 3, 0. So now between this and this, you have to look at what are the coordinates of my vertex based on the equation that I have. So let's say if this graph says 1 and this is 2, and this says 1, 2, 3, 1, 2, 3, okay, so minus 3, minus 2, minus 1. So now you will compare the coordinates of the vertices and see which one is aligning with this equation. So just to summarize, right? First thing is you have an equation. By looking at this equation, so now let's look at one equation and then try to find out what are the properties that we can figure out by just looking at the equation, and then that will give us enough clue to find out how do we graph it or how do we visualize that. Okay, so are you guys with me so far? I'm not picking anybody's sleep, right? Okay. Now let's say I have an equation called, let's look at two equations and evaluate the properties of both the problem. Okay. So this is, let's say, x squared by 16 minus y squared by 25 equal to 1. And another equation is x minus 3 squared by 36 minus y minus 4 squared by 49 equal to 1. Now, what will be the coordinates of the center for this parabola? I'm just giving you guys some clue, okay? So just try visualizing this. First thing, when you look at this equation versus this equation, let's look at this equation for now. X squared by 16 minus y squared by 25. So first thing that we observe is, okay, there is a negative. It is not eclipse. It is not eclipse. This is not ellipse. And this is a hyperbola, right? That's the first understanding we'll build. Look at this one. Here also I have a minus. One term is positive, one term is negative. So this is also equation of a hyperbola. That is the first interpretation by looking at this equation itself, right? Now, from this one, what are the coordinates of my center for this? From this equation for the hyperbola and from this equation of the hyperbola, what will be the coordinates of the center? Any guesses? And guys, participate with me, okay? I want to know whom I am getting confused. Yeah? Tell me, what is the center of this hyperbola versus center of this hyperbola? That means I'm not teaching well. Okay, let me give it a shot. So here, by 16 I can say 4 is squared. By 25 I can mean 5 is squared. Similarly here 36 is nothing but 6 squared and 49 is nothing but 7 squared. Okay. Now here x squared by a squared minus y squared by b squared equal to 1. So here I don't see anything x minus something or y minus something. So this clearly tells me that the center of this hyperbola is at 0, 0. If it was not 0, 0, I would have had something here, which is not the case. So this is the simplest form of the equation for the hyperbola. If I look at this one, I see that it's x minus h by something squared minus y minus 4 by something squared. So here h is 3 and y is k is 4. So here my center is 3, 4. Are you guys with me so far? Just by looking at this equation, I'm not doing anything magical, okay? Now, if I have to plot this, my first gut feel would be that, okay, fine, this is my center here. In this case, my center is at, let's say it is 1, 2, 3, 1, 2, 3, 4. So here, my center is at this place. This is my center. So I identify the center in both this situation, okay? Now, this guy says, now let's look at the second interpretation from this one. Here my x term is positive, here also my x term positive. So interesting fact here is, both are side facing or upward or downward facing.
Are they upward side facing?
They are side facing. If my x term is positive, they are side facing. As simple as that. I'm not going to go back to again explain to you guys saying how did we arrive at that. But if you ever get to recall this formula from this equation, okay, you will see that in case of x being positive, I get a minus, and if I get a minus, then this is inside this, yeah, little below this asymptote, yeah. So simple or faster interpretation that you can carry with you always is, if my x term is positive, it is side facing. If my y term is positive, it is upward and downward. Okay? Is that okay? Okay. So Prisha, who all knows Hindi here? Dev knows Hindi. Prisha knows Hindi, I believe. Dhanushi doesn't. So in Hindi, Chris also knows Hindi. So in Hindi there is a word called Maun Vrat. When people promise themselves that, okay, today I will not speak. So that's a kind of a fast which is called silent fast, meaning nobody is speaking. So I was when you guys were not speaking, I was thinking that somebody has taken, made a promise for not speaking today. Okay, anyway, that was a bad joke. Let's continue. So, and another thing from this one is my slope. My slope of any hyperbola is nothing but the slope is nothing but b by a. That's what we saw when we got y equals plus minus b by ax as the asymptote, or these two lines which will define the boundary of this one. So b by a, this defines the slope. So now from this one, what is by a? A is 4. What is by b? That is 5. Here what is by a? A is 6. What is b? B is 7. So here my slope of the asymptote is b by a, which is 5 by 4 or 1.25, whatever you call it. And here my slope of the asymptote is 6 by 7. Now, with all that information, what you will do is, you found out that where is the center, what is the a and b value, and what is the slope in both the scenarios. So this 7 by 6, my bad. So it becomes 1 point something. 6.16. Okay. And don't catch me on this one. I did not do calculation. Okay, just assume something. Now, so if I try plotting this one, I know my center is 0, 0. So this is my center. And what is A? And then we found that this is facing sideways. This is also facing sideways, right? Why? Because my x term is positive. So just by looking at the equation without doing any mathematical, or dealing with any mathematical jargon, we have found which way it is facing. Now, let me plot these two and then I'll let you guys go. We still have 10 minutes, 15 minutes, right? Okay, good. Now, this is my center for this guy. And what is my A value? A is my distance with the vertices along the x-axis. This is my distance with the vertices along the y-axis. So anyways, this one is not bothering me right now because I know that this is facing sideways. So, and this is my center. So I am essentially talking about my hyperbola like this. Now, what is the coordinates of the vertices? My A is 4. So this will be 1, 2, 3, 4. So it will be 4, 0. Okay. And this will be obviously 1, 2, 3, 4. Minus 1, minus 2. This is minus 4. So my coordinates will be minus 4, 0. Okay. Yeah. So we have plotted this hyperbola. What did I miss here? I missed to put the asymptote, which is having a slope of 1.25. Meaning, for every increase of x by 1, my y is increasing by 1.25. Every increase of x in 1, so basically if it is 1, my y is, let's say 1, 2, 3, 4, 5. When x is 1, y is 1.25, somewhere here. When x is 2, y is 2.5, here. When x is 3, 3.75, here. So I will draw this asymptote. Again, don't go by my drawing skills. And this line, the other one will be obviously 90 degree to that, and the slope will be minus 1.5, 1.25, negative of that, right? So I did not do a good job with drawing of this one. So now I will draw this hyperbola like this. So if you look at this, this is not touching the asymptote. This is just getting very, very, very close to this, and it's like teasing the asymptote. Okay, just gets very close to it, disappears and moves away. Same way here. This gets very, very close to this guy and teases and moves away. Yeah. So this is when you have an equation of hyperbola, these are the properties that you will be able to derive without doing much of a calculation, and that helps you visualize or draw how the parabola would be. So simple thing, you will get all these values, draw the asymptotes, you define the boundary of it, and then find out where is the vertices by looking at the A and B value. Yeah, and then tease the asymptote, and done. Now this is the second equation that we were talking about. So now is everybody with me? Was this able to give you guys some meaningful inputs on or with respect to what? How do you deal with hyperbola here? Just by looking at the equation. Now let's look at this thing. We'll do the same stuff, nothing different. We have all the information with us. So here if it is 0, 1, 2, 3, 4, 5, minus 1, 2, 3, 4, 5. Or I'll use 2, 4, 6, 8, 10. Now it is minus 2 and here also minus 2, 4, 6, 8. Okay. Now, where is my center now? My center is at 3, 4. So 3, 4. We are talking about my center being here at the hyperbola. It's not at the origin of this coordinate plane. It's not the center of the coordinate plane. This is here. That means, and we know that this is aligning sideways. So basically we are talking about it's aligning along this axis. Now, what is my slope? Slope is 1.16, meaning for every one increase of x, my y is increasing by 1.16. So if it goes from 3 to 4, it goes from 4 to 5.6 maybe. When it goes from 4 to 5, it goes somewhere here. Okay. So, though I did not draw it well, but it will be shallower than this one. This is looking steep, but yeah, you will find out the asymptote, the line of asymptote, and then draw a perpendicular line. This defines the boundary within which your hyperbolas are going to lie. Now, look at this. What is the A value? A is 6, and A6 is 6 from the center. So this is your coordinate 3, 4. This is 6 from the center. So you will move 3 plus 6 will be 9 somewhere here. 9, 4. This will be the one vertex of your hyperbola. Okay, and then again you take a mirror image of that. So this is 3, 6, 9. So here you have to go 6 in this direction. So it will be somewhere here minus 3. So minus 3, 4. This will be the second vertex of the mirror image of this one, or along the second, third quadrant. So now, what did you guys observe here? When you look at this equation versus this equation, everything remains the same. What happened was, this hyperbola was here. You just fixed the asymptotes, and then you define the boundary of your hyperbola, and then you dropped it by looking at the length along the x-axis, and then you shifted it and made sure that this gets close enough to the asymptote, but doesn't overlap, doesn't kind of intersect that. Here, when my center moved by 3, 4, my center moved from 0, 0 to 3, 4, meaning I had a standard form, but with center not coinciding with the origin or the center of the coordinate plane. You literally saw this thing shifting. I mean, if I had given you guys this equation and the other equation saying x minus 3 squared by 4 squared minus y squared by 5 squared equal to 1, y minus 4 squared by 5 squared equal to 1. What I meant was, here I am just moving the center by 3 along the x-axis and 4 along the y-axis. So whole thing which was here, that would have shifted on the coordinate plane like this. Not here, maybe here. The asymptote would have been here somewhere. And you would have seen how it is shifting. So basically, there could be different scenarios. As long as you read the equation correctly, and from that you are able to visualize where my center is, where my vertices are, what is my length along the x-axis for the vertices, what is my length along the y-axis. So here you will see that, okay, length along the y-axis is probably not making much sense here because there is no major minor radius, right? So you will think that b is coming into picture. When we look at the situation where my parabola is, not parabola, the hyperbola is facing upward and downward, that is where you will see this coming into picture as well. Okay? So it's nothing but A is your distance of the vertices along the x-axis and B is your distance along the y-axis if your hyperbola is facing upward or downward. But summary of this is, we just need to understand what is my equation, how do I interpret which way my hyperbola is facing, how do I find out the length, the coordinates of the vertices, and then how do I find out the asymptote which defines the boundary of my hyperbola, and then draw it. As long as you interpret and relate to this thing, you will not, or you should not be facing any problem with respect to hyperbolas. There is one more concept to this which is called foci, like the way we learned foci for ellipse, same thing applies here also. And so let me just give you guys a little bit of insight into that, and what I would want is you guys use these concepts and try doing the unit test, and if you get stuck, I will come to your rescue. So quickly, so if you remember, when we talked about ellipse, this is my major axis, minor axis, major radius, minor radius, this is my major radius A, this is my minor radius B, and from this we found that when we say foci, what we mean is there are 2 points along the major axis which are symmetric, meaning the distance from here to here and here to here are same, or you can look at it this way also. So this to this is also same. So what these 2 points, these 2 are called focal points or foci of an ellipse. What it means is, what it says is, you pick up any point on the boundary of the ellipse and join from here one foci to this one, focal point to this one, and this to this. If this is D1 and this is D2, so D1 plus D2 will be equal to always 2 times A. A is the major radius. This is one property that we learned about. And then we found, then we also derived how do you find out if from here to here, this is called focal point, and here to here this distance is called focal length. If I call that as F equals square root of A squared plus B squared. And we saw how that happens, right? So we kind of proved that in the previous class. If you don't recall, just watch the video one more time, and then if I have confused you guys now, I'll come after this. So this was with respect to ellipse. Same thing applies for hyperbola also. It says that same equation. If this is my origin, this is my vertices, A comma 0, this is minus A comma 0. So here it says this also has similar property where, let's say, this point and this point are called focal points or foci of the hyperbola. So here also it says the same thing. This will be equidistant from the vertices. This is symmetric again. And in this case, it says the focal length is where A is the major radius or the larger denominator. I mean, let's say if I'm saying, I'm just missing out on the term that you call it. If I have my equation for the hyperbola like this, and if this is I'm missing the term actually. So let's say this is A and B. It says always you have to look at the bigger one minus the smaller one. So square of the bigger radius minus the square of the smaller radius. This will be equal to the focal point will be focal length will be equal to A square minus B square. And there's a way to prove it also. So we'll prove that. So, but here also it says the same thing. If you pick up any point this length plus this length will be equal to, is it 2a? Yeah, it is equal to 2a. Yeah, it is equal to 2a. So if this is d1 and this is d2. So sum of these two is equal to 2a. And then how do you, these two are called focal points. So sum of this is equal to a square minus b square square root. Now, how you relate in the case of ellipse also, any point on the perimeter, sum of the distance from both the focal points equal to 2a. Here also says the same thing. You pick up a point here or you pick up a point here, any which way. Sum of these two distance from here to here plus here to here will be equal to 2a. 2 times the larger intercept that you are looking at. And these focal points, distance of or the length of the focal point is equal to square root of a square minus b square, where a is the larger radius and b is the smaller radius. I'm just saying radius here in case of hyperbola, it's not called radius, but length along the, just take a difference of the square of both and then take a mod of that. So that's what it says. So foci concepts are the same. Focal points hold true in case of hyperbola like the way it does in ellipse. Only difference being you have focal length. Here in this case it is square root of a square plus b square. It is difference of the squares of the two and mod of that, meaning the actual value of the difference. Yeah, you'll ignore the negative sign. So that is how we will use this concept for doing all the tests or all the attempting all the problems that are there in the Khan Academy. And in the next class, before I pick up the next topic, I will just prove this formula for you guys, so that at least you don't really have to think, why did this teacher tell us to memorize this formula? There is a reason for this. Like the way we proved this formula, we will try proving this formula also next class. Any questions? Are you guys all clear? Did I really do a good job? Alright. Okay. Alright. So, fine. That was I was just trying to console myself that okay, I am doing okay. Alright. So, with that being said, I'll let you guys go. Have your dinner. Take some rest. And whenever you get time, you can probably watch this video to revise what I talked about, because probably I rushed through a couple of concepts. But if there's something that you end up forgetting, this becomes your source to revise it. If something is still confusing, you know whom to catch hold of. Yeah? Alright? See you guys next time.
Thank you, sir.
Alright, bye-bye.
Bye, sir. Thank you.
Bye-bye, bye-bye. Bye-bye, bye-bye.